Hey everyone, welcome back to my daily coding series. Today is day 76. So let's check out asteroid collision. I haven't looked at this question. I also want to point out too, my videos are not meant to be tutorials. It's kind of just like my live problem solving process. So if you're, looking for the best way to solve it, it's probably not on this channel. I mean, it could be, but okay. So yeah, it's just me. I haven't read this before, so I'm just gonna solve it. So, or at least try to. So we're given an array asteroids of integers representing asteroids in a row. Okay. It represents their relative position. For each asteroid, the absolute value represents its size and the sign represents its direction. Okay, so this is an asteroid going to the right of size 10. They all have the same speed. Figure out the state of the asteroids after a collision. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two moving in the same direction will never meet. Okay. So 10 and -5 collide, resulting in 10. So it doesn't get like decremented or anything. That would be a cool variation to this problem, as if this one then became 5. Like 10 minus 5. So these collide and explode each other, and here the 2 and the 5 collide, and then the 10 and the 5 collide, right? Yeah. Yeah. Okay. So it's sort of like there's like a time to it. So okay, so there's some cases I don't exactly understand. So what if you had, so you're almost like condensing. So let's say we had -2, let's say -3, 2, -2. What if we just had this? Like, oh, okay. So these going to the left are always colliding. So these are going to the left. So this would, this can be ignored. So kind of an interesting thought is if we have any negative numbers at the beginning, they can actually be ignored because they'll never collide with anything. And similarly, if we have positive numbers at the end, like this, these can also be ignored because they will never collide with anything. So the interesting part is actually in the dot dot dots there. So in other words, the leftmost positive, so you can reduce the problem to be between the leftmost positive number and the rightmost negative. So this is where the actual problem is. Everything else can just be sort of like condensed. So I should give myself example problems that start with a positive number and end with a negative number. So if we had like 4, 8, -5, and yeah, so this is interesting now. Okay, so -5, let's say 6, but anything can be in between. So I'm just basically putting random numbers as long as this makes sense here. So this should be negative. Okay, so in this case, so there's going to be two collisions. Yeah, there's going to be two collisions. So I guess you could go just left to right. So I was trying to figure out if the order, so my question is, does the order of collisions ever impact the result? So if I have like one collision, let's say -2 and 3, and then like another collision, let's say -3 and 4, does it matter which collision goes off first, or does it not? So this one would be 3, and then this one would be 4. What if this was the negative would win, right? So then we'd have -5. So I guess whichever way it happens, it doesn't really matter because they're still going to have to collide anyway. So yeah, so the output, so okay, so this is interesting. So these parts will always be in the solution. This part has to get condensed to exactly one asteroid. Yes, this dot dot dot, assuming that the dot dot dot, the leftmost is a positive and the rightmost is negative. It has to be condensed into one asteroid. So a way I'm thinking about approaching it is going left to the right, and using a stack where we add positive numbers to the stack because we know the first one that we encounter must be positive. So we're gonna have 4 in our stack, and then we'll have -5, and then we can, like, -5 will never. Okay, so it might not necessarily be condensed to just one asteroid, because then this would become part of this left group. So okay, so we'd add -5, and then we'd encounter a 6. So if this was -7, for instance, we would just add it to the stack. And we just keep kind of adding to the stack, I believe. So if, okay, so then 6, we add 6, and then for 7, we see that, so that's not there. So we add 6. If we were to encounter, so, okay, so before I start doing ifs, let's just walk through this full example. I'll just write it down as a note. Okay, so if we have 6 and then 7, so this overpowers that, so then we have -7, and then -10. So then our answer becomes everything on the left, the stack, and then everything on the right. So what if we encounter 2 positives in a row like this? So if we have like 8, right? So then this would be the same. When we add 6, we'll also add 8. Then -7. So I guess you would, like, let's say if you had like -infinity, this would break everything. So you just keep breaking, you keep popping from the stack until you encounter a negative number. So you'd have -7 would lose. Now -10 would pop this off the stack. So we'd say, like, this asteroid gets broken. So we pop that off. And then this asteroid gets broken, so we pop that off as well. So we may never even, maybe we should only store positive numbers in the stack. So if we had like a, let's say like infinity and then a bunch of negatives, so we would have infinity in the stack, and then none of these would break it, so they would all just kind of, we just skip them. And then if we had like 9 here and then -10, so we'd add the +9, and then this would delete it. So it's almost like we add positives to the stack and then delete them if there's a negative. And then we'd have to know what would our final result be. So in this case, our final result would be just like all the positive numbers in the stack. But if we had this, like -infinity, so let's say we add our positive to the stack and then pop it because this is greater than it, and then we add 6, and then we add 8, those are positives. -7, we just skip it because it's not bigger than the top of the stack. That's it, we don't even check 6 because it didn't break this one. -10 breaks this one, so we remove it from the stack. And then it breaks this one. So we'd have to somehow, like, maybe what we could say is if a negative rock destroys all asteroids in a stack, add that to the result. Like if the stack is ever empty, then we add that to the result because it means it went all the way to the left. Similarly, if our stack is not empty at the end, we will add that to our result. Okay, so let me walk through a solution using this in mind. So my general idea is, so first, like start the problem. Actually, now that I'm thinking about it, we can, if we use the logic I just said, so any negatives that encounter an empty stack are part of the solution, and any positives remaining in the stack are part of the solution. Okay, so if I got a random one, let's say, I don't know, -5, 3, 6, -10, 5, 6, let's say 5, 8, -7. Let's say something like this. Okay, and then we have our stack. So, and then we have our solution. So our solution will be just an array. So -5, we're going to check the stack. It's empty, so we're going to add it to our solution. 3 is positive, so we'll add it to our stack. 6 is positive, so we'll add it to our stack. -10 will pop from the stack. It's bigger than it. So I guess we check, is it bigger than the top of the stack? If it is bigger than the top of the stack, delete the stack, like the top of the stack, and then repeat. So is it bigger than the top of the stack? Yes. So we delete it. And now is the stack is empty, so that means we add it to our solution. Okay, then we add 5 and 8. -7 is not bigger than the top of the stack, so we just skip it. And then 9 is 9 is part of it. And we don't know if these are part of the solution yet, because if we have like negative infinity, if we have a negative infinity, then it could remove all of them. So whatever is in the stack at the end, we just like add it to the end of our list. So our final answer would be this. Okay, so let's try coding that up. All right, so let's try coding that up. So we'll have a stack, and we'll have our solution. 1 second, I'll be back. Okay, I'm back. Sorry about that. Yeah, so I was saying, so we have our stack and our solution. And then I guess we're just going to iterate through every element. So we'll say for asteroid, in asteroids, I'll just say A. So now we want to check. So if A is greater than 0, what if it is 0? Can it be 0? No, asteroids cannot be 0. Okay, so if A is greater than 0, then we'll say stack.append A. Otherwise, we will continuously remove from the stack. So we should say if the stack is empty, then we will solution dot append A. So if it's empty, yeah, but we have to constantly check if it's empty. So what are the conditions that we want to check? So while stack, so while there's something to destroy, and the top of the stack, so the top of the stack is smaller or equal to u. So if a is greater than or equal to, so if my size, so this has to be positive, this is negative though. So while there's something to destroy and this asteroid's size is bigger than the top of the stack, we will stack.pop. And then eventually when it's empty, so there's two conditions. It could exit because the stack is empty or because it can't break it. If it's empty, then it will just append A. And then at the end, after we're done looping, we'll say solution.extend stack. So that will add all the remaining positive ones, and then we can return solution. Okay, so I'll try running that and see if I get any syntax errors. So sol. Okay. Okay, I forgot about this case. So if two are the same, we destroy both of them. Okay. Okay. So we could say this. So while it's greater than, and then we could check if absolute value of A equals the top of the stack. So in this case, this would just exit. What we would do is destroy just the top one. So we would destroy the top one, and then we have to make sure that we don't add it to the stack. So I think if I do it in this order, it may just work. So, okay, so we'll exit. We'll keep destroying until we're either smaller or equal to. If we destroyed everything, we should add it to the solution. This probably should have an else statement though. Yeah, because we don't want both of them to run no matter what. So if it has an element in it, yeah, it should be in this order because we should check if the stack is empty first because we're trying to access the stack. So if the stack's empty, then we found a solution. If the stack is not empty and they are equal, then destroy the top of the stack and don't add this one to the solution. So that'll just like basically destroy everything, which is how we want it. So let's see if that logic works. Okay, I'm not printing anything, so let me try submitting it. Okay, perfect. Great. Okay, so let's see, is there, I mean, I think this looks pretty good, to be honest. Yeah, I'm happy with that. So that'll be today's video. I think it was 76 today. So thank you guys for watching. I thought this was fun, even though it's, you know, it's nothing crazy. I enjoy how it was like about asteroids and stuff. It kind of made it feel more like a game, and I like to do game development sometimes, and this reminds me of a scenario that you may encounter where data structures and algorithms are useful, and it's kind of a fun way to put this stuff to practice. So yeah. Anyway, so that was day 76. So thank you guys for watching, and I'll see you tomorrow.